Hello, my name is Jamie, and today we're going to talk about CadQuery workplanes. The goal of the video is to go through workplane documentation and explain its concepts. Some prerequisites for this video is that you have Python installed, pip installed, Git installed, virtual env wrapper installed, and CadQuery installed. And you can do all that via a video I already made called Install CadQuery on Windows. The next requirement is that you have CQ Editor installed. And you can do that with the video I made called Install CQ Editor with CadQuery. And the link to this entire script for the video will be included in the description of this video. All right, so let's get started. First thing I want you to look at is CadQuery Concepts. And what this is a breakdown of concepts for CadQuery and basically definitions of kind of keywords you're going to see coming up all throughout. It's a good idea to kind of pause the video here and work through this document and get some idea of what's going on with this thing. But for the sake of this video, I'm going to be bouncing around to different parts of this documentation and going over specific sections. And the first place we're going to start is the workplane class. So the workplane class contains the currently selected objects, a list of shapes, vectors, or locations in the object's attribute. The modeling context in the CTX attribute and CadQuery's Fluent API methods is the main class that users will instantiate. Okay, that is the workplane class. Sub of that is workplanes. Most CAD programs use a concept of workplanes. If you have experience with other CAD programs, you will probably feel comfortable with CadQuery's workplanes. But if you don't have experience, then they're an essential concept to understand. Workplanes represent a plane in space from which other features can be located. They have a center point and a local coordinate system. And highlight that expressly. Most methods that create an object do so relative to the current workplane. Usually the first workplane created is the XY plane and also known as the front plane. And those are keywords. Once a solid is defined, the most common way to create a workplane is to select a face on the solid that you intend to modify and create a new workplane relative to it. You can also create new workplanes in anywhere. Well, that's an interesting way. New workplanes in anywhere in world coordinate system or relative to other planes using offsets or rotations. The most powerful feature of workplanes is that they allow you to work in 2D space in the coordinate system of the workplane, and then CadQuery will transform these points from the workplane coordinate system to the world coordinate system, so your 3D features are located where you intended. This makes scripts much easier to create and maintain. See CadQuery Workplane to learn more. We're going to do just that. So, what does a workplane take? First off, it comes off the CQ, the CQ import, CadQuery import. When you instantiate it, it has a couple different parameters. It has the plane, which is a string for what plane it exists on. Um, yep, it has an origin point. That's interesting. I didn't know you could expressly set it right there, which is a tuple of 3 values for the x, y, and z for the origin where it's placed. And then, what is OBJ? Oh, okay, okay. We'll get to that. We're gonna ignore for right now. Um, the return of that is a workplane object with the coordinate system matching the supply plane. So a very brief basic example is S equals workplane on the X and Y. Okay, so, and that covers pretty much what I want to start as a preamble. Okay, so instantiation. So create a workplane on the XY axis with one point starting at 0, 0, 0. That's 0x, 0y, and 0z. And so the line of code here is result equals cq.workplane.x and y. And what you'll get out of that is nothing, right, for the view. So let's test that. So I'll go over here, and I already have the code, so I have CQ editor open. We're gonna import in CadQuery as CQ. result is going to equal CQ.workplane on the X and Z, and we're going to show object, which is our result. We'll run it. And so it doesn't look like it did anything, but what happened is it made effectively a 2D coordinate system on the X and Y coordinates with a center point right in the origin here. And next step is let's append a sphere to the center point. So I'm going to grab this code. And so we get our work plane. Off of here, we're going to basically override result with the current result modified to add a sphere of with a radius of 1 millimeter. There we go. And so the reason why the sphere was placed here is because the origin point is in the center of the work plane. You know, it's at the 0, 0 point of the 2D grid. Um, in general, when objects are placed on the work planes that are native to that API, they are centered. So if we say centered equals false, this will now be offset in the positives by 1 millimeter. So let's roll that, and hopefully this works. Yes, on all three axes. So the origin point is still here at the 0, 0 point. It's still here at the 0, 0, but the sphere is no longer being centered. And okay, let's remove that. Yeah, we'll remove that for now. Okay. And here's the picture of the output. All right, centering. So let's look at the documentation for center. So off of workplane, there's the center method. Shifts the local coordinates to the specified location. The location is specified in terms of local coordinates. And basically you set an X coordinate and a Y coordinate. And both of those are floats. And what this returns is the workplane object with the center adjusted. So the existing workplane object. So let's grab this code and we'll modify our first line to add a center. And so what that did was it did a push. So first off, we made a work plane. We created an origin point with the new X and Y. It's interesting that that changed colors. With the X pushed off 3 and the Y pushed off 3 as well. And we can modify that so you can see some difference here. There, now so the Y is up higher. And so the X is up 3 and the Y is up 3, and then the sphere is centered on that origin point. All right. Cool. And where I bring, oh, cool. So where I landed it out, so I got to change my my dock a little bit. That should be 3.2, because in this next screenshot it's a little bit off. All right. So now we move on. So we have work planes and we have a center point. Now we're going to start talking about the stack. And let's go back to the concept page. So the stack. As you work in CadQuery, each operation returns a new workplane object with the result of that operation. Each workplane object has a list of objects and a reference to its parent. You can always go backward to older operations by removing the current object from the stack. For example, workplane, some object faces, greater than z, first remove vertices. And I'm not sure I'm going to talk about what this is doing in detail quite yet. So this returns a category object that contains all the vertices on the highest face of some object, but you can also always move backwards on the stack. You can browse stack access methods here, stack methods and selectors. What does that have real quick? All size. Yeah, we're not going to talk about that right off. So basically the stack is your working context. And let's go back to the code. So let's start talking about what's going on with that. So by default, a work plane has one point on the stack. So when we made our initial work plane, it has one origin point, and all operations are applied against that point. To prove that out, let's add a box to the work plane. So we'll modify our code to look as follows. And so we're going to generate a work plane on the X and Y. We're going to move our origin point to over by 3 and up 2. Then we're going to grab our result, add a sphere, and we're going to append off of that. So this returns a work plane. This returns the current working stack. So it's going to return the work plane with the origin point. Off of that, we're going to make a box with a length of 1 millimeter, a width of 1 millimeter, and a height of 2.5 millimeters. So let's add that. Bam. And so this is centered. So what happened is we added a circle. Then at the existing origin point that was moved off to this position, and then we added a box at the same exact origin point. And currently the stack is linear, so we have a stack with two objects on it and one origin point, two solids. Okay, now let's get a little weirder with it. So because the work plane is in relative dimensions, if we change the initial axes and the created solids are rotated, so if we change, if we change initial axis and the created solids are rotated from our perspective, but really the work plane has now shifted. And so what I'm doing is I'm going to change this string value. So instead of being X and Y, we're going to shift the work plane to be on the X and Z. Okay, let's run this. And so now the work plane is going along the X and the Z axis, and then all of the operations are being applied on the work plane. So our work plane is being created on the X and Z. We're moving the center points uh, over 3 and up 3, and then we're going to make a sphere and we're going to make a box. Now we can change this, instead of being on the X and Z, we can change it to Y and Z. And now it's moved again. So now, if I rotate this guy around, same idea as what we were doing, but now we're dealing on the X and Z context. So we've now shifted the 2D work plane. Let me change it back to the X and Z because I think the other examples have it as such. Okay, there we go. All right, now let's talk about chaining. So notice that we're calling box off of sphere. And what I mean by that is we're calling sphere and we're calling box directly after that. This is chaining. Let's look at the concept for chaining. So all workplane methods return another workplane object so that you can chain the methods together fluently. Use the core workplane methods to get an object. Use the core workplane methods to get at the objects that were created. Each time a new workplane object is produced during these chain calls, it has a parent attribute. That points to the workplane object that it created. Several CadQuery methods search this parent chain. For example, when searching for the context solid, you can also give a workplane object a tag, and further down your chain of calls, you can refer back to this particular object using its tag. And so the short and gist of that is when we have uh, a method call, this method call will return back its current work plane. And then we can continue doing further operations off of the work plane. And at the end result of this, so we have result, we create a sphere. Off of the work plane, we create a box. Again, this returns back a work plane, which is fed back to result, and then we're going to display back the combinatorial of these operations. Um, So we could also rewrite our code to look like this, and that might help show this chaining concept. So here's our CAD query. We're going to make a work plane. We're going to move our center, add a sphere, add a box. And all of these are doable because at each operation, we're returning back the current work plane. Run this code. Bam. And did that actually? Oh, okay. So in this example, I've already changed my axes. Okay, that's cool. Or we could write the same code as such. So instead of being one line, we can write it broken up by using these parentheses. This is the same exact code, except now you can comment out parts of it. So let's run it. Comment out box. And here is our sphere, right? So, and again, this is playing off the method chain. So you could still chain more operations off of this, right? Um, all right. So let's move the box independent of the sphere. So we're going to change it up a little bit. And in between sphere and box, we're going to call workplane. Let's run it. Now, this did something a little different. So what this is doing is off of the sphere, it returns back a workplane. When we call workplane off of workplane, it creates a copy of the existing workplane and it moves the offset of the along the z-axis. In this case, we're saying move the offset of the z-axis by 2. And then off of that workplane, the new workplane that we've made, the copy, we're going to basically assign our box. Um, and what did that do? So we now have a workplane with the circle, with its center moved. And we also have a new work plane with a new origin point, setting the original circle work plane as its parent. And that's where we're assigning this box to. So there's now two origin points on two different work planes. And I have it right up here. So this is hopefully your output that you're getting. So so I'm going to restate what I just said. Calling work plane off of the sphere makes a new copy of the existing work plane and sets the original work plane as the new work plane's parent. When we then offset the new work plane's origin point height by 2 millimeters on the z-axis, which is being translated to the y-axis in the final output. And uh, to kind of take that out of the equation, if we move this to the x and y, okay, so now we're working an x and y coordinate system. When we say offset of the origin point, so we do our center along the x and y, bam. So we go over 3 up 2. We're going to make a circle. We then make a new work plane with an offset of 2 along positive 2. So we're going to move the origin point up here. And I say move the origin point, but we're making a copy of the origin point and moving it up here. And then we're going to add our box. If I change the coordinate system to say x and z, all those operations still happen, but in the final output, they're translated to the world coordinate system. And not x and y, x and z. And you'll get, it looks like a rotation, but the net effect is it's still, within these work planes, they're still working relative to the global work plane. All right, and if I change it to y and z, I'll be back to the example code. The tutorial code. All right, and let's look at the documentation for this sub workplane method. So CadQuery workplane class workplane method. What does this do? Creates a new 2D workplane located relative to the first face on the stack, or origin point in this case. And it has some various attributes. So the offset for the workplane is normal direction. Yep. Invert, Boolean, or none false. What does that do? Invert the normal direction from that of the face. And that's interesting. Center option, how the local origin of the work plane is determined. The origin is that's a vector, or yeah, okay. Origin of the plane for the plane center requires project origin center options. Cool. So, and what this returns is the new copied workplane object. The first element, so let's go into the description of this thing. The first element on the stack must be a face or a set of coplanar faces or a vertex. If a vertex, which is this case the point, then the parent item on the chain immediately before the vertex must be a face. And maybe that's changed a bit since. The result will be a 2D working plane with a new coordinate system set up as follows. The center option parameters sets how the center is defined. Options are center of mass, center of bound box, or project origin, center of mass, and center of bound box are in relation to the selected faces or vertex vertices. Ugh, that is garbled mess to read. Project origin uses by default the current origin or the optional origin parameter if specified and projects it onto the plane defined by the selected faces. The z direction will be the normal of the face computed at the center point. The x direction will be parallel to the y plane if the work plane is parallel to the global xy plane. Fascinating. The the x direction of the work plane will be coincide the global x direction. Most commonly, the selected face will be planar, and okay. That actually does have meaning. And the work plane lies in the same plane of the face, i.e. offset equals 0. Occasionally, it is useful to define a face offset from an existing surface, and even more rarely to define a work plane based on a face that is not planar. Okay. And so the key trick here is basically we're setting, I'm going to go back to we're going to expand on this a bit. Um, what the goal here is we're trying to get you comfortable with what is a work plane, what is entails when you make a work plane, and understanding kind of the stack that when you start manipulating the stack, when to copy, when not to copy, and understanding because this is key to a lot of stuff. Whatever's on the stack applies to the iterations, how often it'll be applied, right? So let's play with this a little bit more just to kind of hammer this home. So we have a box. We're going to go off the script a bit and we could do something simple, something dumb. So we'll make a new work plane and we'll say we'll offset this by, what is our box size? 1 by 1 by 2.5. So we'll offset this guy by 1.5. So we'll make a new work plane and let's add another box. And we'll call this one uh, 2 by 2 by 3. All right, and that's going to be a little bit weird because that means I need to move that center point. So let's just do it by 2.5. So that'll make my life a bit easier. And did it move it? Yes, but I got my offset wrong. Let's just move this guy up. There we go. And what if it was 3? There we go. And the reason why I'm having to do this is because of that centered equals true by default. So if I say centered equals false, bam. And then this now gets back to what I was thinking. So because this tells you directly where the origin point is. So we make a sphere, we make a box, we make a new work plane, and here we're setting the origin point from somewhere in here to go up by 3.5. And this corner right here is directly where that origin point is right now. When I tell the box to be centered, the box moves to this origin point down and over so that the box itself is centered. And let's do that. And you can see it. And so if I set my center to be higher, my offset to be centered, we can start seeing a space in here. So somewhere the origin point's up in here. So now we have one work plane, two work planes, three work planes, and each of these are chained. So if I went back to, uh, should it just have parent available? That's a great question. Should you have parent? What does that return? Do you have parent? Yeah, you do. Which is just the work plan itself. So can I add a box? One. Maybe I don't want a box. Maybe I want a sphere. Think about that. Yeah, let's say box 1-5-1. What does that do? So I'm saying parent because we're doing an offset here. Let's tag this. We'll tag this as equal to center. Because I'm trying to see if I can break this. I'm probably doing a very good job of it. Tag center. What does that do? I want CadQuery tag. Does that work? I know you have it. Yeah. Oh. Workplane. Ooh, there we go. I want that. And what did you do? You didn't change a whole lot, but I don't think you're broke. Workplane, bump, 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 bump. Let's go to box. Where is your code for box? Workplane.box. It's probably doing a demo on the fly. Upper, lower. All right. So workplane box parameters. Do you have a tag? No. So I can't put the tag there. I need to put the tag on the workplane itself. Wrong spot. So if I put the workplane here, and let's go to the documentation for workplane, because I'm off the rails a bit, but I'm learning too. Workplane object from tag. Do I have to define it that far up? Workplane. All right, I'll make tag into its own. Should be able to get this working. Wires. So I can tag wires. So I can tag name string. Okay, let's do that. So we make a workplane. Current C2. Will that work? Yes. Oh, that's cool. So now it gets really weird. But this is a good teaching moment for the stack, right? So uh just for verbosity, let me explain what we did here. So we have a work plane. It's on the X and Y axes. We're going to move the center point of this work plane over by 3 and up by 2. We're going to then create a sphere. And we're basically going to say, create a new work plane, move the offset up 2. From here, make a box. We're going to tag this box, the CQ object, as the center. Whether that's really acting on the box or it's what centering on the origin point, because I'm just doing this on the fly, I can't tell you right now. I don't know, right, what it's doing. We're basically taking this box and we're tagging it. We're then going to make a new workplane object and move the offset up by 4.5. At that point, we're going to make a new box. And we're going to call it, give it a length, a width of 2 and 2, and then a height of 2.5 millimeters. We're then going to grab a work plane from this tagged object. And it might just be doing center of mass. So it might be making a new origin point from that. But we're recollecting, we're going back in the stack, grabbing this work plane, and then we're adding a new box here, which is uh, uh, 1 millimeter along the x-axis, 5 millimeters along the y-axis, and then 1 millimeter in height. So what I want you to understand here is that the stack is a chain of work planes, and you can work your way up and make new ones, but you can also reference back to previous children in the stack. And so we have an array effectively of work planes on the stack. So we have the first level of the sphere, the second level, which now contains 2 solids, and then the third level, which contains our final one. And when we added this box, the work plane we're on is actually going to be the middle work plane right now. So when this returns back, it's going to return at the work plane in the midpoint. So we could do one final weird thing, and we can move its center 5 and 5, just to be wild, and we'll say add a new box of 5 and 1 and 1. What would that do? Yeah. So when this third box operation came back, because it's working off of center, where we're currently on the stack is here. I suppose if we wanted to, we could actually move the stack pointer back up to the child element of this middle stack and move it up to here. All right, so that's enough craziness. And again, we can change all of this relative. So now let's do it. All of this, and this should all rotate about 90 degrees on the z-axis. Bam. Okay. So there's all kinds of fun stuff you can do here. And I'll move on to the next topic, which is push points and iteration. And we're going to start over with a fresh script, a fresh example.